Okay, so we'll start with the lesson first, and then we'll look at the uh, tutorial. Okay. So this chapter is about two sample tests of hypothesis. So remember, the previous chapter we are looking at one sample test. So one sample test means that you are just looking at one particular sample. So you are okay. Let me just write it down here. So if let's say you are talking about one sample, okay. So you have this population, and then from this population, you are taking the sample. So this is population, and then this is the sample. So you want to compare whether your sample mean is equal to your population mean. That is one sample. You are just looking at a particular sample. Okay. If eh, okay, because we are also opening the YouTube. So let me just admit all first. Okay, okay. Um, so if let's say we are talking about two sample, so basically, of course, you're gonna have two population here. This is population one. This is population two. Okay, so you are taking the sample from this population. Okay, this is sample one. This is the sample 2. So you want to compare whether sample 1 and sample 2 are the same. So one sample and two sample are two different things. One sample, you're just looking at the sample mean, whether it is equal to the population mean. Okay, you are talking about a particular sample. While two sample, you are comparing two different sample from two different population. Okay, so now let's move forward. Okay, so this is the continuations of the previous chapter. Remember, I mentioned to you that when we talk about hypothesis, all the 6 steps will apply. Okay. Mm, okay. Okay. So in the second part of the hypothesis, for two sample, you're gonna have two things: independent and dependent. So under independent, you're gonna have Z and T, and I'm assuming that you know when you're gonna use Z, when you're gonna use T, and dependent. While for dependent, you will be only looking at T statistics. Okay, so only two things that we're gonna focus today. Okay, wow. So as I mentioned to you, you are comparing two population mean, right? You want to compare the sample mean for number one and number two, are they equals or not equal? That's it. The examples of it is for you are seeing whether there is a difference in the mean uh, value of residential real estate sold by male and female. Of course, you know that females and males are different, right? So you want to compare these two things. So in the two sample, you will be given two different information. Okay, and the second example is actually referring to the dependent. We will look at the example soon. Okay. So as I mentioned to you, under remember you have dependent and independent. So independent means the two sample are different from each other. For example, male and female. Dependent means you are looking at two things, but they are very closely related. Okay. So under independent, you will be using Z and T. So you are going to use Z when is that? When you know the sigma, when your population standard deviation is given. Okay. So this is the formula. You have to familiarize yourself. So the formula to complete the Z under two sample. Okay. You have X bar 1. This is the sample mean in the first sample minus the sample mean in the second sample. divided with the square root of, you have sigma squared in sample 1 over population over the number of sample in sample 1. So sigma squared is actually your variance. Okay, so you have to take the variance in sample 1 plus the variance in sample 2, and also you have to divide with the number of observation. Okay, so let's look at the example, or else you don't know how to apply the formula, right? Okay, so remember, so in this chapter, you have to know two things. Let me write it down here. Okay, first, you have to know whether, how to differentiate between one sample hypothesis versus two sample. Okay, second, you have to know whether you are talking about Z or t-test. Third, you have to know whether you are talking about one tail or two tail. Okay, so later on when you are looking at dependent, then you're gonna also take notes of the point number 4, whether you are talking about independent or dependent. Okay, at the moment we KIV, keep the KIV the number 4 first, because you will be looking at the independent. Okay, so remember this for information, you have to know when you read the question of hypothesis, whether we are talking about one sample or two sample. Of course, yeah, today is two sample, but you have to know how to differentiate them, whether we are using Z or T, whether we are looking at one tail, two tail, and later on, whether we are answering independent or dependent. Okay, so let's look at the question. Let me just open a new tab. This one. Okay, so I forgot that this is the video. So customer at this supermarket have a choice when they want to pay their groceries, whether they want to pay using standard cashier assisted checkout or self checkout. So you can see that there are two methods of payment, whether the standard one using the cashier or self checkout. So these two information tells you, well, we are talking about two sample tests or two hypotheses to sample, two hypotheses, the same thing, right? And then the second thing, let's just keep reading. The store manager would like to know if the mean checkout time using the standard one is longer. So what do we mean by longer? So longer is you have something like this, longer or bigger. This is, okay, let me put it here. So the first information give you, we are talking about two sample hypothesis. Hypothesis. Because they give you two methods of payment. The second information give you longer. This is keep telling you that we are talking about one tail. Okay, remember we have covered one tail, two tail in the previous chapter. Number 3. What is number 3? Let's look at it. You have to know as well whether this is what this is Z or T. At the moment, they didn't give you the information. Of course, this question is not complete, right? So let's keep moving. I will just move to the next slide so that you can see the whole question. So the whole question, okay, they give you a box of information. Okay. So you can see here you have customer type, standard and fast lane, and then they give you the informations of sample mean. Okay, this will be needed when you want to compute the test statistics. one of the reason why we also have online, because I have this coughing. Okay. And then they give you a population standard deviation. This is your sigma. So when the sigma is given, you're gonna use Z statistics. Okay, you have all this information. But before that, let's see what kind of information they are giving to you, right? So, so in this case, okay, you can say that they are giving you the sample mean for the first sample, second sample. They are giving you the sigma for the first sample, second, and the sample size for sample 1 and 2. So you can see that you are not only seeing one information from one sample, you are seeing two information from two sample. So it should tells you that we are talking about two sample. Okay, so now let's try to solve the question, right? Mm. Let me open a new tab so that you can see a better picture. Okay, what is the information? Okay, so remember you have the same step. Step number 1, you have to state the hypothesis. Okay, so normally, let me put here H0, H1. Okay, so you want to know what is the sign, right? So let's reread the question. The store manager would like to know if the mean, so you are testing the mean, checkout time using the standard. Okay, you have two information, right? Two things. So here the standard checkout is longer. So you put here double dot. Okay, you want to know the mean of the standard. So don't put mean 1 bigger than mean 2. So because you have two things. If you put 1 bigger than 2, I don't know what is your 1. So label them. The standard SS bigger than the fast lane. So put F. Okay, so you have your H1, so H0 is just the opposite and equal sign. So mean for standard is smaller or equal than the mean of fast length. So step number 2, remember you have 6 steps. Alpha. Alpha should be given in the question. Okay, at the moment the question is not complete. So don't worry about alpha so much. So here they decided to use 0.01. Step number 3, you know that you have to use your z, right? Because sigma is given. But what is the formula for z here? Of course, the z formula in one sample is different from the z from two sample. Okay, so this is the z. So you have the mean for standard minus the mean for fast lane divided with square root of variance in the first sample or the standard over the number in standard. So basically all the informations are given in this yellow box. Okay, so I believe that you can just plug in the information inside the formula. So let's assume that you got the answer of 3.123. Okay, because this is just applying the formula. So I don't think you're going to have a problem to apply it. So you got the z equals to 3.123. Okay, that is the z. All the information will be given in the question. So you don't have to worry how to compute the z. Step number 4, what's next? You have to write down your CV. Okay, so your CV will also be the same with the previous CV. You have a proper steps, right? Okay, so let me just rewrite the steps in CV here. You have to refer to the table, and then this is one tel, so refers to one tel. What else? Your alpha is equal to 0.01. And then because you are looking at z, remember when you are looking at z, you will go to infinity. So let's have a quick look on your t table just to refresh your memory. I know that you know, but let's just have a quick look. What was the instruction just now? Go to t table, one tel. So you have one tel here. You have to tell. Remember, look at one tel. What's next? Alpha 0.01. So under one tel, alpha 0.01. But because you want to look at the infinity, so T table has 2 pages. Go to the second page. So look at one tel again, alpha 0.01. Infinity, what will be the value? This one, 2.326. Let me write down here. Equals to 2. I forgot already. 2.326. 3 to 6. Okay, let me accept your friends first. Okay. Okay, so next. Next, after having, so remember the sign of your CV, this is not done. The sign of your CV, because the table will give you positive. So you have to refer to your H1. So the sign of CV refer to H1. H1 is bigger. So bigger means positive. So then what's next? You have to draw your table as big as possible. So positive will be on the right side. So 2.326. So CV will give you the rejection region. Okay, now, let me use different color. This one. Okay. So remember when you are using CV, you have to compare with the Z value. This is your Z. So CV is 2 point something. Z is 3. So Z, of course, Z will is plus, right? Plus is on the right side. Z will be inside the rejection region. Okay. So when the Z is inside the rejection region, number 5. I don't know whether we have a space. We do. So step number 5, what you gonna do? Make a decision. What will be your decision when the Z is inside the rejection region? You will say reject your the H naught. Reject the H naught. Don't reject H1, okay? H1 is your hypothesis. Once you reject H naught, number 6, what will you say? What was the question? So if you, number 6 is you have to interpret your result. When you say that, let's reject the H naught. So you are trying to say the mean for standard is bigger or longer than the mean for fast lane. But this is not how you want to interpret. So if you want to interpret, let's read the question. Where is the question just now? Um, mm, mm. Okay, it says that um, um, you want to know if the mean checkout time using standard checkout method is longer. So you can say, yes, the mean checkout time using the standard checkout method is in fact longer than the fast lane. So just reread the question. Okay, so I'll put here as restate your question. That's it. So very similar with the previous one. Okay, so now let's keep moving. That is using Z. Now we wanna look at the example of, okay, that is the disadvantage of what you call using the video, because they're gonna give you many sounds. It's okay. Let's admit first. Okay. Wow. The morning advertisements always is about food, right? They know that you are hungry. Okay. So where is it? Okay, they give you the formula first. So if you want to use T, so the T formula will be actually complicated, like more than the formula of Z. Okay, you're going to use two formula. First, you're going to use the formula of pool variance. So what is the meaning of pool variance? So basically, you're going to combine all the variance. So what is the formula? Let's look at it. N in sample 1 minus 1 multiply with the variance in sample 1 plus the sample in sample 2 minus 1 multiply with its variance over at the bottom. This is what you call degree of freedom, DF, because you're talking about two sample, right? So N1 plus N2 minus 2, and then you need this pool variance if you want to compute the T. So what is the formula of your T? Mean for sample 1 minus mean for sample 2 over square root of pool variance multiply with 1 over N1 plus N2. Okay. So although the formula is long, but it's not that hard. Okay, so let's look at the examples of the question so that you know how to apply it. Okay, what is the formula? What is the question? This Owen manufacturer what blah blah blah. So two different procedures have been proposed for mounting the engine. So two different procedures. So they already mentioned there are two things here. Okay, so this should tell you this is two sample tests. Okay, what are the procedure? The Wallace method and Atkins method. So you can see in the yellow box, they give you the observation. When they give you the observation, basically it should tell you that, well, you don't know the population standard deviation, you don't know the sigma. So in this case, you have to use T. And then the question is there a difference? The word difference is telling you that you are talking about two, what is that? Two tail, not equal, right? Okay, so you know that this is t-test, two tail, what else? And then this is two sample, of course. Okay, so you just have to write the what we call the hypothesis. You compare the Wallace because different not equals to Atkins, so they will give you alpha. Okay, you're gonna use T formula. Remember, T formula gonna be a bit longer, right? So you're gonna apply the formula of T. So I will not compute the formula. I'm assuming that you know how to plug in the information in the formula because they give you the observation here. So from this observation, you have to compute your standard deviation and the variance. Okay, so all the calculations are given here. Okay, and then once you compute the T statistics, you have to find your CV, the same thing. Okay, so the same thing. First, you have to set up your alpha, your statistic, alpha. Second, third, compute the T. Fourth, you have to find your CV. Fifth, you make the decision. So let's see what happened. Your CV is actually because this is two tails, right? You're gonna have plus minus. CV is between 1.833. So you have to compare what is your T value. T value just now is is negative. Okay, let me write it here. So we will not solve the whole thing because the steps are the same. So you got your T equals to negative 0.662. Okay, and then what is your CV? CV is, okay, CV will tell you rejection region, right? Okay, CV is negative 1.833. And then you also have the positive sign because this is two tail, 1.833. So T is negative 0. So you will see negative 0 before negative 1 point. So your T will be outside the rejection region. This is T. Okay, so basically your decision is do not reject because it is outside the rejection region. Okay, the rest are the same. Okay, let's move to the dependent. We have covered independent. Independent are two different things. You have Z formula, you have T. Now we are looking at dependent. Okay. So some people call dependent as PET test. So what do we mean by dependent? Means that you're gonna have two things, two sample, but then these two samples are very related to each other. Okay. So if you look at the formula, let's look at the formula. Under dependent, you will only be using T, no longer about Z. Okay, so don't worry about whether sigma is given or not given. So to compute the T, you have D bar. What is D bar? Bar is mean, D is different. So you will be using mean different divided with the standard deviations of the different over square root of n. So D is like your observation. Okay, it's like your x, but here is about different. Okay, and for the dependent, because as I mentioned to you, these two samples are very close to each other. They are very similar, so you consider them as one. So that's why the degree of freedom, the DF, is just n minus 1. But for the independent, because these are two different things, so n1 plus n2 minus 2, because they are different. Okay, so let's look at the formula, another formula to compute the standard deviations of the difference. So the formula are very similar to your standard deviation, But standard deviation, you are using X as the observation. For the difference, you are taking about the same thing, square root of summations of different instead of X minus the mean difference instead of the sample mean squared over n minus 1. Okay. Similar formula with the standard deviation is just that the observation instead of X, you are using different. So let's look at the example. How does this examples look like? Because there are two sample, but one is independent just now, one is dependent. Okay, so this nickel saving and loan wishes to compare the two company. So two company tells you that you're talking about two sample. Okay, two company you have Shadex or Boyer. Okay, so this nickel saving select examples of 10 residential homes or property. Okay, they want to compare between these two companies. So the result, okay, reported in thousands of dollars. So what was the question? At the 5% significance level, can we conclude there is a difference? So the word difference is telling you this is about two tail between these two firms' appraised value. So somehow this nickel saving saying that, okay, I want these two company to actually evaluate the value of the house, uh, whether their valuations are different or not. So these nickel savings are selecting 10 homes, 10 houses. So the nickel saving compare between these two companies. Okay. So you can see these are two things, and then this is two tail because it is different. Okay. Um, let me just write down. Let's have a new empty one. Okay. So let's look at the first steps. You have to state your hypothesis. So start with H0 and then H1. If you look at the slide, they put here mean different not equal because this is different, not equals than 0. You can have that. Let me just write down here. Mean difference not equals to 0. So this is just the opposite. H0 just the opposite. Mean difference equals to 0. This is one way of writing the hypothesis for dependent because you are looking at the difference between these two samples. Or you can also write the mean for Shadek is not equals to the mean for Boyer. Okay, so you can also have this way of writing down your hypothesis. Second, the same thing, alpha, they will give you alpha is equal to 0.05. Third, dependent. Okay, so how would you know this is dependent when they are giving you two different company, right? You will think, well, this is independent sample. Okay. Okay. So why this is called as dependent sample? Before we compute the t value using whatever formula, okay, the sample become dependent because they are looking, although they are two different company, but they are looking at the same sample. They have to evaluate 10 different houses, right? For example, if you are looking at the first house, the first home, although these are from different company, but because they are looking at the same sample. So if let's say they are looking at the same sample, so their answer, the evaluation will be more or less similar or the same. Okay, so when you are looking at, regardless whether you are two different people, two different whatever, but when you are looking at one sample, the same sample, I can say the same sample, so your answer will be dependent, very close to each other. That is the examples of dependent. Okay, there are actually two scenario for dependent. This is the first scenario. Okay, we will look at the second scenario. Okay, so let's just go to how to complete the T. Okay, where is it? You're gonna have a long working. So you have the home, you have the valuation for Shadek and Boyer, and then remember you are talking about different. So how to find different? Different is like the first one minus the second one. You can have Shadek minus Boyer. The difference is 7. Okay, so take the first company minus the second company, you will get the difference. The difference is just like your observation. So to find the mean difference, remember you have to compute d bar. So the same thing, how to find the mean? So you take the observation, which is your difference, summations of 7 plus 5 until 4, you got 46. To find the mean, 46 divided with 10, you will get the mean difference. And then just compute the standard deviation using the information given. Okay, so once you have mean difference, you have the standard deviations of the difference, you can apply the T formula. Okay, so let's assume that you know how to. This is just a plug in your information into the formula. So you got your T equals to 3.305. T equals to 3.305. Next step, don't forget your CV. CV will give you the STEM steps. That's why I mentioned that when you know the previous chapter, well, this chapter will be easy. Okay, that you will be looking at T statistic, T table, and then one tail. This is two tails, right? So the same steps. Okay, so let's assume that you know. Just now I already mentioned how to find the CV, right? So let's assume that you found the CV equals to 2.262. So CV equals to 2.262. Remember, your T table will just give you positive value. So the sign of the CV, what will you do? Okay, you have to look at the H1. H1 here is what we call two tail. So if two tail, you have to carry plus minus. So when you draw a diagram, don't forget plus minus. So you have negative 2.262. This is plus 2.262. So this is rejection region. So let's see where is your T value 3. So you start your rejection region at 2. So 3 will be inside the rejection region. So when it is inside rejection region, step number 5, let me write it here. When you want to make your decision, you will say make decision. You will say reject H0 because it is inside the rejection region. Step number 6. So when you put step number 5, you just mention reject H0. No need to say because it is inside rejection region. That is just my explanation. Just put reject H0. And step number 6, you want to interpret. How to interpret? Remember, reread the question. What was the question? Can we conclude there is a difference between the two firms' appraised value? Because you reject H0, so here H0. You reject the H0, of course you will say, what we call, there is a difference between the firm's appraised value. Just read it, the question, okay? So that is the examples of dependent sample. Okay, let's continue. Oh, it's done. So remember I mentioned to you there are two scenario when you're going to use dependent. The first one, when, let me use a different one. So for the dependent sample, there are two scenarios. The first scenario is that when you are looking at the same, I want to put, when you are looking at the same sample. Okay, the same sample are evaluated by two company or two people. Let me put here two people. Okay, so these two people are just looking at, okay, let me put here. This is the sample. Okay, this is the same sample. But then it is evaluated by two people, people A, people B. Because A and B are looking at the same thing. So you call it dependent sample because the answer for A and B will be almost the same. This is the first scenario. Okay. The second scenario, you call it intervention study. So intervention mean, okay, this is also the examples of dependent. Intervention mean you're gonna have, of course, two things, two samples, but the samples are very similar. Okay, so let's look at, they give you the example in the slide. Suppose you wish to show that by playing music in the production are able to increase the production. So let's assume that this company are having low production. What kind of production? Productions of table. So the tables, for example, during the night shift, the table produce are very low. Okay, so before the intervention, okay, so you are talking about intervention. Before the intervention, so this company uh, are only able to produce 10 table per night. Okay, per night shift. So the company said that, okay, the manager said that this is too small, right? Too little. Let's have some intervention here. What is the intervention? Let's play music. So that when you play music, people will not be sleepy, so they can increase their production. When you are listening to a good music, so you are happy, so you are not sleepy, so you may produce more. Okay, so they play music. So music here is what we call intervention. Okay, and then after they play music, they look at the after intervention. So this is before intervention, which is your music, and this is after intervention, which is your music. So after intervention, maybe the manager sees that people are not sleepy, people are happy, so they are able to produce 20 table. Okay, so you can see that we are looking at the same people. You are looking at the same worker before they play music and after they play music. They want to see whether the productivity of the same worker will be increased or decreased. So we are looking at the same thing. Previously the same sample, but now the same worker, but then they're going to have before intervention 10 production perhaps, after production maybe, after intervention maybe increased production. So the same thing. That's why you call it dependent sample, because the sample are the same thing, but then you gonna have two different values. Okay, so done with the tutor the lesson lecture. Do you have any question before we go to the tutorial session? Anyone wanna ask question? Oh, you are ready for tutorial? Huh? Anyone wanna ask something? I cannot see you, so you have to tell me. Do you have any question?
No, madam.
Okay, thank you. I know that you want to play your game, but because this is online, so I will be the one who is solving the question. So let's see the exercise. What do we have today? Uh, chapter 11, right? Go to page. So everyone, please go to the page 408, question 3. 408, question 3. Okay. So for hypothesis testing, remember you only have 6 steps, which you have to remember by heart. The tricky part for hypothesis is not to compute the formula. It's not about how to memorize the steps. No, because the step is just 6. Okay, so that is something simple. The tricky part for hypothesis testing chapter is that how you are able to differentiate whether we are talking about one sample, two sample, and the later chapter they will be also looking at different um tests. Okay, so now when you are reading the question, remember I mentioned you have to figure out whether we are talking about one sample, two sample, one tail, two tail, Z or T, or maybe independent or dependent. Okay, when you are deciding this is two sample, so you have to figure out, is it independent, is it dependent? Okay, so that is your first task to do. Okay, let's look at the question. Gibbs Baby Food Company wishes to compare the weight gain of infant using its brain and versus its competitor. So you have the Gibbs company and the competitor's company. So there are two company. So this should tell you two things, two sample tests. Okay, right? So the second, uh, so when they are talking about two sample tests, they should give you two different information. So what are the information? Let me write it here. Okay, remember when you are talking about hypothesis, list down the information. A samples of 40 baby. So this is a sample using Gibbs. So the sample for Gibbs you are talking about 40. And then reveal a mean weight. So the mean for Gibbs. So remember, don't put just mean 1, mean 2, put the label. Mean for Gibbs is equals to 7.6. And then for the Gibbs brand, the population standard deviation. Remember? So they put here population standard deviation. Sigma for Gibbs. What is the sigma for Gibbs? Is 2.3. Okay, that's it. And then they give you another information. A sample for 55 babies 55 berries using the competitor. Then you're gonna have a different information for competitor. The sample is 55. And then you are also expecting that they give you the sample mean for competitor. Where is the sample mean? 8.1. And then you're gonna also have sigma for competitor, which is 2.9. So now you have all the information, right? Okay. At the 0.05 significance level, can we conclude? The question will tell you how to set up your first step, how to set up your hypothesis. Can we conclude that the baby using Gibbs brain gain less weight? So less should tell you this is one tail. So let me write it here. Maybe you want to see different color. So step number 1. So H0, H1. Okay, where is just now? Can we conclude that babies using Gibbs brain? So you are looking at mu for Gibbs less weight compared to mu for competitor. This is how you set up. You have two things. So less will tell you one tail. So just rewrite the hash null. Instead of less, you put the opposite and equal sign, mu for competitor. Done step number 1. Step 2 is even easier. What is the alpha just now? They mentioned the alpha is 0.05. Number 3. Number 3 is computing your z, right? Why z? Because you are given the sigma here. Sigma. So by looking at the sigma, you have to compute the z value. Well, I forgot what is the formula for your z. Can we refer to your z formula? Or the formula will be a lot. Let's just write it here. Z is x bar 1 minus x bar 2 over square of, you have sigma squared 1 over n1 plus sigma squared 2 over n2. Okay. Okay, so now these are your information. So x1 is your Gibbs, right? So what is the mean? 7.6 minus, what is the mean for a competitor? 8.1 over square of sigma. So sigma, but you need the variance, right? So sigma for the Gibbs 2.3 squared over, what is the n? N is 40 plus sigma for competitor 2.9 squared over the number 55. I don't have my calculator with me. So by having this information, you should be able to compute your z value. Okay? So I trust that you know how to compute your z value. So next, after finding the x and the z, step number 4 is computing your CV. So remember, the step for computing the CV, you have to refer to the table. The same steps, nothing changed, no difference. Okay, I don't know your CV, but I believe that you can compute it using the steps. Okay, I'll leave it the CV to you. Okay, but remember, the sign for your CV will follow the H1. Here, your H1 is less. So your CV will be negative value, whatever the value here. Okay. So step number 5, you have to make your decision. Decision. So when you make your decision, you have to compare what? You have to compare between your answer for Z here and then the answer for CV. If let's say Z fall under rejection region, reject H0. If not, do not reject. And step number 6, You just have to integrate. The rest will be the same. Okay, so you can see that Z just use the formula, CV will be the same, decision the same. The only difference is that you have to know whether this is one sample or two sample, whether this is Z or T, whether one tail or two tail. That's it. The rest will be the same. Okay, so let's look at the next question. Where is the question? Page number 419, question 17. So 419, question 17. Okay. So basically, this question is just to illustrate, to give you the examples of. Just now we have applied the Z. This is just the example for T. Why it is T? So this is actually clear cut. Okay, you can see that they give you the observation. When they give you the observation, of course you don't know what is the sigma, right? What is the population standard deviation? So you have to take note. Okay, you have the observation. You have to compute the value. This will be T instead of Z. So remember what is the okay, you have to know. So the first thing, oh, this is T, right? Not Z. All right, who just joined the class at this hour? Okay, let's see. Okay, so this is T, not Z distribution. Second, okay, because it is obvious, right? Okay, so let's read the question. Miss Lisa is the budget director, and she would like to compare the daily travel expenses for the sales staff and then the audit staff. So you have two types of staff, sales and audit. So this will be two sample hypotheses because you are talking about two things. So you are comparing sell staff versus audit staff. So this will give you two sample hypotheses. Next, step number 3. Not really steps. Number 3, we want to find the key words, right? The point. She collected the following sample information. Blah blah blah. At the 10% significance level, can she conclude that the mean daily expenses are greater? So the word greater tells you that this is greater. Greater will tell you that this is one, not one sample. This is one tail test. Okay. And what else? Oh, remember, you have to consider whether this is independent or dependent. Number 4, is it independent or dependent? So sales staff and audit staff are two different people. Of course, this will be independent sample. So the rest of the what we call the steps will be the same. You're gonna have 6 steps. And the question even asks you, on top of they ask you to use the 6th step, what is the p-value? P-value, remember I mentioned in the previous chapter how to find the p-value? Okay, you're going to have a proper steps. And in this chapter as well, there is also a section that I keep mentioning how to find the p-value. Will be the same step. Okay, you have to follow the steps. Okay. Let's just keep moving. Okay, because you have to know how to differentiate them. Okay, next question is page 429, question 24. 429, 429, question 24. This one. Because this is the question from the textbooks, right? So it is easy. So they already mentioned to you the null and alternate hypothesis are this. So you can see that, well, this is mean difference. So mean difference means this is the examples of dependent. Okay, so you don't really have to think hard. Is it independent? Is it dependent? They already mentioned this is dependent. But trust me, in the exam question, we will not give you the answer this kind of question because we want you to set up the steps from 1 until 6. At the moment, they already given you step number 1. Okay, so let's just keep going. The following part observation. So when you look at the word pet, pet is actually another name for dependent sample. So this should tell you, well, if let's say the first information is not given, you also have another information to tell you that this is dependent. Show the number of traffic citation given for speeding by Officer Dot and Officer Meredith. So you are having two officers. So this is the examples of two sample hypothesis. Okay. So you will be saying that this is two different officers, like the sales staff and the audit staff. But remember, they tell you this is the pet observation. So this should be dependent. And they also give you the hypothesis for mean difference. So this is also another indicator that this is dependent. Okay, so let's assume that at the moment you have two clue, right? 2 point. Let's keep reading. There are many points to tell you that this is dependent. Okay, so these are Officer Dons and Officer Meredith. So they are giving speeding citation or speeding ticket. Okay, by looking at this table, yellow table, it can tell you that we are not talking about independent sample. We are talking about dependent. How? Even though these are two different officers, but they are looking at the same month for Officer Don and Meredith. So in May, okay, they are giving two value. So when you are, remember the scenario for the dependent, if let's say they are looking at the same thing, but then they are having different value. When you are looking at the same sample, these are the examples of dependent. Okay, so at the 5% significance level, is there a difference? A difference words will tell you that this is to tell. So you have to tell, you have two sample, and then dependent on top of it. And then of course, when you are talking about dependent, you will be using T value instead of Z. Okay, so I'm giving you all the clue because you know how to do it. It's just that you should learn how to differentiate between one sample and two sample hypothesis. The next question is, we are almost done. 429, question 25. Question 25, just down there. Remember, for dependent, you have two scenarios. The first example is giving you the first scenario. The second example is the illustrations of the second scenario. So the management of discount furniture, okay, design an incentive plan. So you want to give incentive, right, to motivate people. For the sales people to evaluate this innovative plan, 12 salespeople were selected at random, and their weekly income before and after the plan were recorded. So when you look at the keywords before and after, remember I mentioned that when you have an intervention, you will see the value before and you will see the value after. So the word before and after should tells you that we are talking about dependent, and this is the case of intervention. Okay, so you will see the salesperson for 12 people, and then they have different value. Before the intervention, what is the intervention? Intervention here, the manager give or whatever the company give incentive. What would you think when you are given incentive? Will you work harder or lesser? Of course, right? You know that you will get more incentive, you will work better or harder. Okay, so you are expecting that after the difference will be larger. Okay, remember when you want to come out with the hypothesis for dependent, slightly different, right? Let me use different color. So you can have step number 1 for hypothesis H0, H1. You have two ways. You can put here mean difference. Okay, so you believe that because of the incentive, people will work harder, right? So mean different, you can say mean different what? Um Harder, right? So the difference okay, there are many ways here. And the easy way, instead of mean different, you can put bigger than 0 because you are expecting that the difference is larger compared to before. Let me put here mean different less or equals than 0. Okay. Another way that I would actually prefer is where is the different color? So you put here H0, both are acceptable. H1. So mean for uh, after, right? You expect the after will have bigger impact compared to the mean before. Of course, after you receive the incentive, you will have, I don't know, more, you will work more and then you will get more income. Okay, so this is just the opposite mean after, less or equals than mean before. Okay, so this is another way of stating your hypothesis. Some people, okay, sometimes, if I'm not mistaken, the textbook also write it in a different way. So let me use different color so that you know that why it's like this. Okay, you can also write it this way, but I prefer the purple color. You can also write it this way. H0, H1 mean of what we call you start with before. Mean before, of course, will be smaller than the mean after. You can also have this way. Okay, and then mean before smaller than this is the opposite, bigger or equals than mean after. Okay, you can also have this way, but because you expect that after receiving incentive, of course you will have more income, so this will be more accurate, the purple one. Okay, although the blue and the green one are also acceptable, but the purple is clearer and uh, better way of explaining your hypothesis. Okay, so that's it. I think we have covered all the example for the formula. 429, yeah, 25, yes. So okay, so we have the lecture, and then we also have tried the example to cover all the formula. So now, do you have any question before we end our class? I know that you love to end your class early, right? But do you have any question before that? Anyone?
Madam,
Yeah.
I have a question about the survey that we need to redo, right?
Redo.
Redo some survey, right?
Okay. When let's focus on the lecture first because
Okay.
we are recording it, right? So
Right.
after we've end the recording, then we will discuss about assignment. Okay. Anyone
Um,
else? Can you ask about anything you want to ask about the lecture?
for,
Anyone? Anyone else? Do you want to ask about lecture? About the question? About the tutorial?
no.
No. Okay. If no question, let me. Okay. I don't know what happened. Let me just end the tutorial and the recording. Okay, manage recording, stop recording. I forgot. Remember you're gonna have your midterm, the coming class. Okay, I did put the announcement for your midterm. You will what is it? You will cover from the first chapter until, of course, we have covered this tutorial, right? Chapter 11. But this is too short. I don't think, let's just give you more time. So we will not cover for today's chapter. We will just cover until last chapter, which is chapter 10. Okay? Take notes of it. And how long is your quiz? How long is your midterm? We will conduct it during the class time. So it should be within the class time. You can finish early, you can finish, just the maximum is within the class time. Okay. And how many question? Of course, I don't know how many question. I haven't designed it yet. But big but the question should be sufficient during your class time. And whether you're gonna have MCQ, whatever, most likely the MCQ will not be there because I wanna see you you're working. Okay. So we're gonna have a paper-based exam, paper-based midterm. So I want to see your working because when I can see your working, sometimes the end answer will be wrong, but along the way your working is correct. So I still want to give you some marks. That's why it's good to have paper-based exam. Okay, so that is about the announcement for the coming class. So I will stop the recording so that you can ask anything about your assignment.